One of the most important concepts in coastal geology is the beach system, which exists whenever the coast is characterized by abundant sediment that is pushed around by wind and waves. The beach system is a geologist term that is very different from the term beach, which is used by regular people to describe the sandy place where you lay out your towel and you throw a frisbee. Geologists call that place the recreational beach, and it is but one part of the beach system. This image shows the whole beach system. It encompasses all the sand that is commonly moved around by wind and waves, with the exception of the largest waves which may permanently relocate the entire beach system somewhere else. But these really large storms are very rare. They happen maybe once every several decades or so. So most of the time, sand inside the beach system stays inside the beach system, though its actual location may change rapidly and frequently. The beach system has three parts: the sand dunes, the recreational beach, and the submerged portion of the beach, which often includes submerged sandbars. The submerged portion of the beach extends offshore to a depth where normal storm waves, can't move sand. This defines the offshore limit of the beach system. Everything within the offshore portion of the beach system represents sand that is accessible to regular and normal storm waves. Common beach processes move sand between these three reservoirs of sand. Sometimes this movement is slow, like the accumulation of sand in the dunes by wind, and sometimes the movement is rapid, like the movement of sand from the dunes and recreational beach into the offshore beach during large storms. But as long as the sand remains in the beach system, it isn't lost and may later be relocated back from where it came. In fact, this movement of sand perpendicular to the beach is a common response to changing energy conditions along a beach, changes that are often seasonal. Here I've shown how a typical beach responds to changes in wave energy throughout the year. In Florida, stronger storms generally occur in winter. These stronger waves attack the beach and dunes and transport sand towards the submerged beach. As this process continues, the recreational beach, which I've noted between the two red arrows, shrinks, while the submerged beach, especially the offshore sandbars, grows. The recreational beach also becomes flatter in response to the stronger, more energetic waves, but this flattening comes at the expense of the width of the recreational beach. The final image shows the configuration of the beach at the end of the storm season, which in Florida is typically at the end of the winter. Just about now, right about there. Summer brings fewer storms and calmer seas, and the beach once again responds. The smaller waves cause the sandbars to migrate toward the shore, piling sand up against the recreational beach and enlarging it. In addition, onshore winds blow across the naked beach and pick up sand grains and carry them toward the back of the beach. When the wind blows through grasses and vegetation, the velocity slows, the sand drops out, and dunes start to accumulate. This is why vegetation on dunes is so important, and why many restoration efforts are focused on getting plants to stabilize the sand. Not only do the roots stabilize the soil, but the leaves play a very important role of baffling the wind and causing sand to drop out and accumulate, thus feeding the growing dune. Notice that as the sandbars migrate shoreward and attach to the recreational beach, the beach face gets steeper, but the beach gets wider. Notice that the distance between the red arrows grows during this process. You can see it starting there. There it is. The little dots represent the sand and the recreational beach sand being carried by wind, and the recreational beach is getting wider and wider and wider as the sandbars are getting attached to the front of the beach. Here's a summary. When this process is seasonal, the winter beaches are formed by stronger waves and tend to have a narrow but flat recreational beach in many offshore bars. Much of the sand in this case has been relocated into the submerged part of the beach, right? Most of the sand lies out in the sandbars. During the low energy summer, the beaches are the opposite. The recreational beach is wide with a steep face, and there are relatively few offshore bars. And in this case, most of the sand is located in the dunes and the recreational beach. Now, regardless of whether this is seasonal or not, this cycle repeats itself over and over again. In some cases, it's seasonal. In other cases, it only happens once every decade or so when a really large storm comes in and drastically reshapes the beach. But as long as the sand hasn't been transported out of the beach system, the beach always recovers to its low energy state with a wide recreational beach backed by healthy dunes. So people shouldn't get concerned when the dunes disappear and when the beach narrows, because as long as the sand remains within the beach system, it will return to that state. This process of moving sand from the dunes to the offshore portion back to the dunes is a cyclical one that happens with regularity, and this is what beaches do. They constantly change as sand is moved within the different reservoirs of the beach system.